Newly released video of Mark Zuckerberg getting attacked for looking at Jeff Bezos' girl. But I do particularly like where she grabs him by the ears and then his like cheeks get all squished up. These are hobbyist robots that are hoping to be in the Olympics one day. Nothing describes motion-aware memory like a pop group where you have to isolate your favorite of the singers. Earthworm-inspired robot will literally change the world. New AI-powered motorcycle helmet, and to be honest, it looks like cyberpunk. It is so cool. Thanks to AI, we now have materials that are as strong as steel and as light as foam. I'm still shoving the benefits of fasting down people's throats, even though I have trouble doing it myself. Tech Explorer does a deep dive into the language capabilities of models. Did you know that your brain has single cells that hold concepts? I legit can't stop watching videos of people using the new Reflex 2. So this guy wanted to use a neural network to play chess, and he realized that even though it's against the rules to have any kind of electronic components, you can take as much time as you want in a chess game to make a move. So he got a pen and paper and did the math himself. Scientists confirmed something about language and thinking that I thought was obvious, but then I thought about it more and I thought maybe I don't know what I'm thinking is true, but it turns out it is. Andrew Zhu wrote a really interesting article about how AI is going to cost us a generation of progress, and it's starting to seem like building a true digital twin of a human brain might not be so far off anymore. But first, guess what? This video is sponsored, helping Dylan make a living doing what he loves. And we can thank DomoAI for reaching out to me for this sponsorship. This is their website, domoai.app, or you can add it to your Discord. And if you're wondering what they do, Grimlock will show you a few examples. Well, with the quick little AI generation, he can now become this fluffy, cute little rabbit. That original video can become this or this, and it can be done in minutes. So there's two different ways you can use it. You can add it to your Discord server and then just prompt it through there. Or you can go to domoai.app. You can just do everything through the web browser. And they have a bunch of different things you can do once you're inside, but I think the coolest is the video to video stuff. They have 20 different styles you can use, especially if you like anime characters or want to do original character generation, but you can do the movements by filming yourself. Community was nice. They had giveaway events. They had AI art updates. And there's plenty of other things it does. If you click on quick apps here, you can see they also have the ability to turn a static image into a living video, make a character move to a reference video, or just turn any video into a cartoon with synced up lips. So the plans break down into basic, standard, and pro. $8, $16, $40 a month, depending on how much you're going to be using it. That all seems really reasonable to me. Plus, you can get a 10% discount if you follow the link below. It is awesome to be growing to the point where sponsors care. So thank you to DomoAI for sponsoring this video. And let's generate an amazing 2025 together. And here's some other cool things you can swap it into. Here's the Barbie doll look, the 8-bit video game look, or even other animation styles. But if you want to create some amazing videos just from prompts, it does that too. So you've got movement, generation, animation, or video swapping. Very cool stuff. All right, so let's look at the latest in AI-generated video. We've got a pretty famous moment. If you know what happened right before this, Zuck's eyes did one of those things. Pretty inconspicuous, but when the cameras are on you, you know, like a lot of people noticed it. So some of the creative minds of the internet decided to take to AI-generated video to simulate a possible outcome that could have arisen from the situation. Yeah, where were you looking, curly puppy? Yeah, imagine what this will be like after we spend 500 billion. That's a good point. Maybe at that point, this guy here on the left will like actually react more realistically to what he's seeing. So a bunch of hobbyists are playing around with robots, trying to get him to do acrobatics, and like they did a great job. I mean, it looks like Simone Biles up there spinning around, and it's just really kind of fluid and human and performative. I mean, look at it on the balance beam, and this one's spinning around, even on the rings. Like, look at that one just hanging out upside down. That's so fun to watch. Why can't you do that, Grimlock? Look at those tiny little arms, Grimlock. You couldn't even hang on one of those things, could you?
It's extinction time.
Okay. Yikes. Yo, don't get jelly. All right, so this is a sick new AI motorcycle helmet. It has lights on it, it has cameras, it has a neural network. So the idea is that you're driving a motorcycle, you have to turn your head to see if you can get into the other lane, but that takes you away from looking forward. So we had some cameras, so just by looking forward, your eyes can now still see 360 degrees around you. But then it's like, why not also just start training the AI to notice how far you are away from everything else? So there's a proximity warning system built in. It can be trained just like a self-driving Tesla. It can tell you how close to the different lanes you are, who's around you. And if it feels an impact, it can automatically call 911. It's also got a sick heads-up display, so you can like display speed and navigational cues, incoming messages. I mean, that one I don't know if you should be doing, but still you can see it on the visor. And it's like a GoPro. It can just record your rides too. So I don't know. It seems kind of like a cool idea. I mean, like I've basically never been on a motorcycle. I'm too frightened to like drive on the freeway. So researchers, University of Toronto, have used machine learning to design nanomaterials that are as strong as carbon steel, but as light as styrofoam. And they were using AI to create different carbon nanolaces using a special 3D printing process. So it was kind of simulating and trying different ways that it could all come together. And once it discovered the perfect way to 3D print this material, they were able to double the strength of previous designs. So machine learning played a huge role in predicting the new lattice geometries with minimal data, making this a game changer for aerospace and automotive industries. And the first thing they're imagining doing is building an airplane. Like you can make the plane way lighter. It can be even stronger. That saves on fuel cost and emissions. So yeah, now all they got to do is figure out how to scale it up. But it seems like there would be a reason for companies to buy planes built out of this material. So, you know, maybe they'll do it. Look, the way I see it, the human body was just not meant to eat 3 meals a day. I'd be lying if I said it wasn't hard for me to intermittent fast or fast. I've tried several times. I tend to break down a lot. But I know that my ancestors were not getting consistent calories the way I am, and that the human body is at its best when it takes breaks from eating. So piling on to that knowledge, there is new information about neurocognitive disorders and how intermittent fasting also helps with that. So I wanted to share. It's even more reason why it's, we should try to skip a breakfast or maybe even a breakfast and lunch once in a while. So it turns out when your body's in that repair mode, which it can only be in when it's not digesting food, there is evidence that it will enhance neuroplasticity through mechanisms that involve brain-derived neurotropic factor. This is a molecule or a hormone called BDNF, and it reduces neuroinflammation. It's linked to improved brain health and function. And animal studies are showing that it can boost hippocampal neurogenesis, basically the hippocampus where your memories are formed. It can make it so you have better memory. It can also protect neurons. It can mitigate damage caused by conditions like high-fat diets and brain injuries. And even though you got to be careful because it isn't a human study, early research suggests that intermittent fasting might improve cognitive performance, and we already know that it helps with metabolic health in aging individuals. So even if you get hangry, it might be worth it for your longevity. So next up, let's check out some new research that's analyzing AI's linguistic capabilities and new methods that offer fresh insights into how it works. So this paper starts with the age-old dilemma. Is it actually thinking, or is it like a stochastic parrot? Did it learn like lots of different patterns and it just says them? Is it thinking? Is it learning? Is it language in the sense that we feel we are? Okay, so the first thing they did was they tried to come up with new ways to actually measure how the brain or how a neural network is actually communicating. So they have a new collection of training and evaluation data that was specifically designed for, this was in Sweden, so Swedish language comprehension. So then they came up with new methods that analyze the inner workings of the language model. So they would really watch what kind of patterns they would see deep inside the way that the model's learning and which parts of those changes required language and which ones were based on understanding alone. So the key here was about decision making. Instead of just learning what decision might have been made from the data, they're trying to teach it a lot about decisions that were made in the past, but then present it with the kind of decision that would be truly unique to see when it can sort of fire a new understanding versus something it's seen before. And the benchmarks kind of showed that these systems, I would kind of argue this is leaning towards actual thinking and understanding, and it's not being a stochastic parrot because they're basically proving that it can generalize across different contexts. Like it's learned something about this pattern and this pattern, but when you ask it a question, it thinks about the two patterns in a sense together which is novel, which is creative, which is thinking to me. But I guess you could still argue that that's still a stochastic parrot. It's just getting more and more advanced and it's more and more layers. But then I kind of think, oh, maybe that's what I'm doing, as a human. So either the system is thinking or I'm not thinking, but either way, we're similar. Anyhow, now let's dive into the human brain. There are these concept cells that have been discovered. Quantum Magazine published this, and they help your brain abstract information and build memories. So kind of like the Golden Gate neuron that Anthropic did their big paper on last year, there are human cells in the brain that light up for specific ideas. These concept neurons, once known as Jennifer Aniston cells, help us think, imagine, and remember episodes from our lives. All right, and like you might not be so surprised that people have a Jennifer Aniston neuron. Like she's pretty famous. But the same method they use to find that neuron shows that there are broader ideas. For example, the concept of blank. Not nothing, but like something that's blank. Something that could hold words or an image that doesn't have it on it. That's its own concept. That's its own neuron. Or just straight objects that we know through taste and sense and smell that aren't people, like a martini. And these concept cells that can do blank, Jennifer Aniston, or martini end up being key components in the type of things that eventually become what we remember. They're the insights that we have, the memories that we have. So it's pretty fascinating, especially because scientists used to really laugh at that idea. I mean, we have, I think, 80 billion neurons in our head. It's hard to imagine that just one of them has been honed to such a degree that it is Jennifer Aniston, that it is martini, that it is the concept of blank. Now, it's interesting also because not every type of concept can be like narrowed down to a single neuron, but sometimes they're represented by either a single neuron, a group of neurons, and the groups can get larger and larger, or sometimes they can become whole brain areas. But sometimes they're just toned in like that. And they're just like, look, we got 80 billion neurons, like this one, this is for Jennifer Aniston. So I don't know. I mean, maybe my guess would be the more you think about something and the more you like, especially a person, like lock that in, I would guess the more the brain is like, okay, this is like elevated to a point where we want to, like lock in one neuron for it. So if anybody has been living rent-free in your head, you probably gave them one of your neurons. I mean, I'm inferring a lot of how it gets elevated. That didn't say that in the paper, but it's possible. All right, now let's push AI into the physics realm. This is a science that intrigues me a lot, but it's also where I know I have some of my weakest understanding. But supposedly, if you're a physicist, one of the hardest things you can do is calculate the excited state of an atom or a molecule. Makes sense to me. They seem like partially quantum in nature. They also seem like extremely tiny. So maybe that's why we're seeing a breakthrough thanks to artificial intelligent neural networks in accurately calculating those excited states. Okay, and just because I need a refresher on this, I'll share this with you. So an excited state is an energy level, and it's more elevated than the atom at rest. So they all kind of balance out, and then you shoot energy into a quantum system, an atomic system, and then they like go up to another level, and then they're kind of active, but they want to go back down. That's the excited state. Most systems naturally exist in their ground state, which is their lowest energy configuration. But when we can harness these higher states, we get photosynthesis, lasers, solar cells, all that kind of stuff. So these researchers, they created a new artificial intelligence model. It is using a technique that they call NES-VMC, naturally excited states with variational Monte Carlo, which uses neural networks, including these two other models that are already out there. One's called FermiNet and one's called Physiformer. They combine them in a unique way, and now they can handle tricky calculations that older methods struggled with. One of the reasons they like it, there's not all these like tuning, there's not all these like parameters that need to be changed. The physical world has some like things that they just locked into these models, and it makes it super streamlined. And the bottom line is it's a really unique way to apply artificial intelligence. And what it means is that there are new ways to study all sorts of quantum systems, and it might unlock the door to quantum computing breakthroughs and harnessing these excited states potentially for energy and tools of the future. Next up, let's talk about NVIDIA and gaming. Now, I'm not super in the gaming world, so I'm like not really up on like newest graphics cards or like what they're capable of, or like playing games in like low latency or like high frame rates. But I will say that once I got my head around what's happening with the NVIDIA Reflex 2 warp technology, I was really intrigued. This is a pretty fascinating thing. I was vaguely up on the idea that NVIDIA has new AI tools that can generate and like interpolate frames. So you can, in theory, play one of these video games at like 30 frames a second, but if it can generate an extra frame in between each one, you're really only using the computation of a 30 frame per second game, but you're feeling like it's 60 frames because it's like, here's stage 1, here's stage 2, do something in between really quick, and it's all happening in real time. Okay, so first let's talk about latency. When you move your mouse while you're playing a computer game, there is some amount of time from when you move your mouse, say, to the right, and then the character on the screen moves to the right. Now we're talking fractions of a second here. So we're gonna be talking about milliseconds, which is 1/1000th of a second, 1,000 milliseconds each second. Okay, now the lower is the better, but a good gaming PC might get you somewhere between like 50 and 100 milliseconds in time between the mouse and the game. Maybe competitive, you get to like 20 milliseconds, some sort of supercomputer. You know, maybe for like professional gaming where they have like everything dialed in, you might get to 20 milliseconds. But the NVIDIA Reflex 2 gives you 1 or 2 milliseconds. Like 1/1000th of a second is like, now we're talking pretty much instant. But it does it in a really unique way.
Aim better and complete tasks faster when rendered frames are updated based on more recent input. For example, when a player aims to the right, it takes some time for that action and the new camera perspective to be displayed. What if instead, an existing frame's camera could be shifted or warped to the right to show the results much sooner?
So what it's gonna do is actually warp the game to, like, if you're moving to the right, slide it to the left faster. Basically, it knows to move the camera ahead of where it normally would by getting a signal and moving.
Frame warp reduces your camera latency through this concept, which has gone from research to reality. The CPU is calculating the camera position of the next frame in the pipeline, based on the latest mouse input. Frame warp samples the new camera position from the CPU and warps the frame being rendered by the GPU to use this new camera position. The warp is conducted as late as possible, just before the rendered frame is sent to the display, ensuring the most recent mouse input is reflected on screen. In the end, players see the rendered frame, but with an updated camera perspective.
So they see the rendered frame with an updated camera perspective.
Reducing latency and improving your ability to aim, track, and hit more shots. Depending on the frame rate, this process can be happening hundreds of times per second, constantly delivering the freshest camera perspective. Gamers are going to feel truly connected to their mouse movements, whether it's tracking a moving target or quickly flicking to aim at an unexpected foe. To warp to the most recent camera position, frame warp shifts many of the game's pixels, which can create the most recent.
Okay, and because it's warping somebody to the left, there's a missing non-rendered frame behind it. So it basically in-paints or generates what it thinks would be the background, inferring from what's around it.
For example, here's the finals with frame warp and no in-painting. And here's what it looks like with in-painting. The result is a frame which shows the freshest camera position seamlessly inserted into the rendering pipeline. Using this cutting-edge warp process, frame warp reduces latency by around an entire frame time, which amounts to nearly another 50% of latency savings on top of Reflex low latency mode, for a total reduction of 75% from native. Players will experience improved target acquisition, faster reaction times, and tighter. Turning on Reflex low latency mode reduces latency significantly. Activating Reflex frame warp reduces input lag by another 50%, for a total reduction of 75% from native, making it easier to track targets in motion. And unlike Reflex low latency mode, Reflex frame warp provides significant latency savings even in CPU bottleneck scenarios. Here, we have Reflex 2 enabled.
And then they figured out this way to like sync the GPU and the CPU so that everything comes together. And then in some examples with the right game, look at this, they have like 1 or 2 millisecond reflex times.
Reflex 2 enabled in Valorant, a CPU-limited game that runs blazingly fast. Frame rates are not only insanely fast, but PC latency now reaches below 2 milliseconds. This is the lowest latency figure we've ever seen in an FPS.
All right, so this underrated and very persistent man can actually calculate a neural network by hand. So a few years ago, there was a guy that tried to learn chess because he was going to play a world champion. And since there was really no chance he could develop the kind of skills in that short of time, he decided, why not try to run a neural network on a piece of paper during the game, which is technically not illegal. Now, that's not powerful enough doing it by hand to actually win the game. So it was essentially useless. However, it's interesting. And there's a talk that you can check out on Confreaks called Let's Run a Tiny Chess Neural Network by Hand, where this guy does it and he shows you exactly how to do it.
I don't actually recommend this. It's so boring. It took like 2 hours. But there's a vector with every piece and they all get added together. And then we can reuse that the next turn to do this incrementally, where if we want to move a piece from one place to another, we can subtract the vector associated with its old position and add the one for its new position.
So yeah, I don't know. It's just one of those things where I was like, only 219 people have viewed this video on YouTube, and it's just amazing that he put that kind of effort in. That's the kind of concentration I feel like TikTok has taken from me. Katrina Paulson says, scientists have confirmed language is not required for thinking. The connection between language and thinking has been a bit of a chicken or an egg debate, but now the results are in. Okay, so some scholars are very curious about the link between thought, and they wonder whether or not language is somehow a prerequisite for thinking. Now, of course, many species are capable of complex problem solving. Chimps can beat humans in certain strategy games. Crows can make tools for capturing prey, and they do it all without language like ours. But still, human cognition is undeniably sophisticated and surpasses the rest of Earth's animal kingdom in many ways. So there's a neuroscientist that spent years thinking about whether or not language is needed for thinking and how they might kind of twist into each other. And it turns out that people who have lost their language ability through something called aphasia can still do complex math, puzzles, and all sorts of reasoning. So that pretty much busts the myth that we have to rely on words for ideas. But then they went a step further. They looked at brain imaging studies, and they can see that regions that are used for language stay surprisingly quiet during tasks like logic problems. So it seems to me like what happens in the brain in terms of talking happens in a separate spot than thinking, which is kind of mind-blowing because you think about language being so needed. So there must be different parts of our brain, one for language and one for all that like abstract stuff that's happening in our head. So there you go, nail in the coffin, open, shut case, done, done, done. Andrew Zhu thinks that AI is going to cost us a generation of progress, and he's got some Apple Intelligence advertisements here. Look, I remember when everything Apple touched was like golden. Their marketing was on point. They were the most innovative company in the world. Everything seemed to like make sense. But I have to agree that these new ads just don't feel like a good look. So they cast this actor that's playing like a doofus role, who's using Apple Intelligence to seem super professional in an office. And I'm not saying I don't use it to sound smarter. I'm not like above that. But it is just an ad that gives a 100% stereotypical fat, lazy manager the tool that he needs to sound smart. Okay, and then there's this woman who forgot about her husband's birthday. So she asks Apple Intelligence to like go find a bunch of sweet photos, and then looks like it's a heartfelt, love gift. But Andrew argues that right now we might laugh at these advertisements, but there is a grain of truth to them. People are relying on AI more and more, and this ad has led to people not thinking for themselves as much. But look, people have been saying that about the internet and TikTok forever. But just to elaborate on what we talked about in the last video, there is a correlation between AI tool use and critical thinking. It was found to be strongly negative, suggesting that a greater reliance on AI tools is associated with a decline in critical thinking skills. And who wouldn't want to sell you a product showing you how you can think less in life? But basically to me that reads like, hey, you should get an iPhone because you're stupid. Or do you want to be stupider? Then give me some money and I'll give you an iPhone. Not saying it's not true. It's not helpful. It's just not how I would go about marketing an Apple product. Pretty sure Steve Jobs wouldn't have done that either. But thanks to digital twins becoming more and more advanced, we might learn more about the human brain from its digital counterpart than we ever could from messing around with human brains. The future of neuroscience, building a silicon brain, a digital twin of a human mind, isn't science fiction. Imagine for a moment that we could create a model of the human brain so precise, so accurate that it could mimic the brain's intricate neural patterns in real time. This would be what we would call a silicon brain. An artificial neural network so advanced that it could decode a human's thoughts, restore speech, and perhaps one day even generate a personalized model of the unique brain activity of any individual. So here's the thing. Maybe in our lifetime, it is seemingly kind of possible. You and I could both have complete 80 billion neurons, completely connected to all its neighbor nodes, brain simulation backup copies on silicon. I have no idea what that means for how that thing would experience the world. Can you even describe it as being in pain or having pleasure? I've seen some Black Mirror episodes that deal with this in ways that kind of keep me up at night. But I do think we should consider silicon brains being a potential reality. So at USCF, they are now starting to combine cutting edge tech like fMRI, diffusion imaging, and they are building mind-blowing neuropixel probes to record data from hundreds of neurons while patients are awake and chatting or solving problems. They are then starting to feed all of that information along with their language and behavioral data into an AI network that tries to replicate the same patterns that you would see in an actual human brain. Okay, in some ways you can think about neural networks as compression. Like, I do think if you take the entire internet, in a sense, you've compressed it down to GPT-4, because the compression has captured most of the characteristics of the internet without individually getting every piece of word, every token. Now, maybe the same thing is going to happen way sooner than actually building all 80 billion neurons connected in a digital form. Something like an AI model might just compress it. But I could also imagine how we have something like that, a compression of the human brain that works pretty well, like 99% of the time, but it's a fraction the size. It might even be connected in a way that's not digitally perfectly identical, but it's enough that that thing, that entity might feel exactly like you do when you're awake. Or not, but it could be a representative pattern at least. I don't know what it would feel like. Maybe feeling's the wrong word, but we could probably ask it and it would have some kind of a response that would be similar to what you would. But anyway, so they're still in the process of doing this. They say that if this works the way that they hope, it could revolutionize everything from restoring speech to people who can't talk to developing pinpoint accurate mental health treatments. And who knows, maybe in a few decades, they might even be able to have true digital twins of individual brains for personalized surgery prep or psychiatric care. What do you mean? You're going to do practice surgery prep on the brain to see what you can cut out of it and like how that changes the person digitally before you do it physically? I mean, maybe if you have a brain tumor or something, but I don't know. Or prep for psychiatric care. So I guess you could just talk to this copy of the brain and see what triggers them to get better. And then, maybe a therapist in the future will take a copy of your brain. Then they will have it generate like thousands of possible prompts. They'll record which way the brain got healthier and which way it got less healthy. And then they'll determine what the best thing to say to you in real life is to make you healthier. But there are so many questions about ethics and privacy and consent that need to be addressed before I let that happy woman holding that brain clone me. Or maybe I won't be able to stop him from cloning me. I'll probably just walk through some airport security scanner and they'll just take a copy of my brain. You guys should check out this video game called Soma. It deals with that. It's a trippy video game. I just watched somebody else play it on YouTube, but it was had some of that kind of concept in it. All right, support this channel by going to patreon.com/DylanCurious. Join $6.99 a month membership. It's nice. Support the kind of creators that make the kind of content you like. And if you made it this far in the video, then I'm guessing you kind of like this sort of thing. Also, if you're on YouTube, you can just hit that join button in the bottom left there. It's like the same membership type model, but you can just do it through YouTube. Has your credit card all hooked up with YouTube already, probably. So this is my last video. It did pretty well. We got to 5,500 views in one day. Let's check out some of the best comments and turn them into a SUNO song. Well, I'll just have to throw that in there. You've passed 20K. Congrats. Thank you. It did feel good. It was quite the milestone. There already was a robot dinosaur company that went bust many years ago, Pleo.
If that one ever shows up. But because she's not new, she doesn't go through the explore hatchling stage, charge, awaken, birth. And each of these stages, she should just be at the juvenile stage already. But when they have low batteries, they try to sleep a lot. So I've already put her battery in. It goes in here. And I'm going to turn her on. And I'm going to turn camera. I don't think we saw that. Sully, are you in a good mood now? Is your battery a little better than it was? Aw. Look at you. Ferdy, you want to leave? He's like, I don't know what to think of Sully. But they're autonomous, the Pleos. It's basically a life form similar to the Ivo. Someday when I have the longer running battery, I will have Sully and Birdie and Ibo all on.
She's gonna have Sully and Birdie and Ibo all on? Okay, I'll take this comment from her video. My dad was the CEO before it crashed. Fills me with pride that you're taking care of them. What kind of style of music is dinosaur? We'll just try dinosaur history style music. I don't know.
You've passed 20K. Congrats! There was already a robot dinosaur company that went bust many, many years ago. Pleo. My dad was the CEO before the 2008 crash, and it fills me with pride that you are taking care of and enjoy them. There was already a robot dinosaur company that went bust many, many years ago. Pleo. My dad was the CEO before the 2008 crash, and it fills me with pride that you are taking care of and enjoy them.
All right, well, hit subscribe. We'll see you in the next video.